Hello class, good morning. So today I will discuss understanding plane figures and congruent polygons that you can find on page 265 to 270. So a plane is a flat and it is composed of endless points that extend to all directions. So it means that it doesn't have height, it doesn't have thickness, okay? That is a plane. So a line is a set of points that extends indefinitely in opposite direction. If we take a part of the line, you will have a ray. So this one is a ray. And you will have a segment. So this one. So you can already determine the difference of ray and segment by given this picture. So the Chuken segment has two end points, while ray, the other side, is endless, while the other side has end. So that is a ray. I will repeat. The segment has two endpoints, just like here segment AB, while ray has one endpoint. So this is the endpoint of ray CD, so its one endpoint is C, while the other side is continuous. That's why there is an arrow. A plane figure is a flat or 2D figure in a plane. So a plane shape can be straight sides or curve. However, this lesson will deal with plane shapes that have straight sides. So now let's define polygon. Polygon is a closed plane shape with straight sides. So polygon, closed plane shape with straight sides. So this one is a polygon and this one is a polygon. Why this is not a polygon? Because it is not closed. And this is not a polygon because it has curved side. So that's the reason. A triangle is a polygon with three vertices and three corners. Just like in the figure, we have three sides: side AB, side BC, and side AC. And we also have three vertices. So vertex A, vertex B, and vertex C. We also have three angles. Okay, so this one is angle A, angle B, and angle C. So that is a triangle. Next is the classification of triangles according to sides. When you say equilateral triangle, all the sides are the same in length. When you say equilateral triangle, all the sides are the same in length. So 4, 4, 4. While isosceles triangle, the two sides, okay, isosceles triangle has two sides of the same length. So the two sides of this triangle is the same. Then this is an isosceles. Okay, equilateral, all the sides are the same in length. Isosceles, the two sides are the same in length. While in scalene, sides of different lengths. So all the sides have different length. So as you can see, 3.43, 4.0, 4.11. So this is the classification of triangles according to sides. Next, let's move to classification of triangles according to interior angles. So when you say right triangle, it means that it has one right angle, or just like a square in a corner of two lines. Okay, so this one is a right triangle because it forms a right angle. Next is acute triangle. When you say acute triangle, has three acute angles. So when you say acute angles, lower than 90. So all the angles or the interior angles of this triangle is lower than 90. That's why we call it as acute triangle. Next, obtuse triangle. When you say obtuse angle, the angle is greater than 90 but less than 180. So given this one, you can see an obtuse angle which is 123.69, greater than 90 degrees but less than 90 but less than 180. That's why we call it as obtuse triangle. So let's proceed to a four-sided polygon is called quadrilateral. So I will repeat, four-sided polygon is a quadrilateral. Remember that some quadrilateral has two pairs of parallel sides, which other have one pair or no pairs of parallel sides. So what are the parallel sides here? Just like in trapezoid. In trapezoid, there is only one pair of parallel sides. So, side AB and side CD. These are the parallel sides of the trapezoid. AC and BD are not parallel. So, only one pair of parallel sides. Next, square. Square has two pairs of parallel sides. EH, FG, EF, HG. So I will repeat, square has two pair of parallel sides. Next, rhombus. So rhombus, so let's go back here in square. Square is a special type of rectangle that has four right angles. So this is a right angle, right angle, right angle, right angle, and all its sides is equal in length, and it has two pairs of parallel sides. Let's proceed to rhombus. Rhombus is a parallelogram that has four congruent sides. So this one, congruent, congruent, congruent. And the last one is a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. So PO, MN parallel, then MPNO parallel. So that's it. Trapezoid, square, rhombus, and parallelogram. So those are some of the example of quadrilateral. And there are also quadrilateral that has no parallel sides. These are the examples. First, we have can place an arrow. So, okay, the first one is trapezium. So trapezium, it is a quadrilateral that has a pair of parallel sides. It has also a pair of parallel sides, line AB and line BC, or segment AB and segment BC. That's why this one has one pair of parallel side. I will repeat, this is a trapezium. Next is kite. It is a quadrilateral with two pairs of sides is equal in length. So it is a quadrilateral with two pairs of sides is equal in length. So EH and GH equal, FG and FE equal. So that is a kite. And next is chevron. It is a concave kite. So the congruent sides are next to each other. So in chevron, okay, congruent equal KN, KL, MN, ay, so this is a chevron. So this one is equal to this side. This one is equal to this side. So let's proceed to rectangle. A rectangle is a plane figure with four right angles and two pairs of parallel sides. Parallel sides have equal distance from each other. Just unlike the other quadrilaterals, they do not have equal distance. So this one is an example of rectangle. So as you can see, it has four right angles, right angle, right angle, right angle, right angle. Then the parallel sides have equal distance. So BC and AD, they are parallel at the same time they are equal in length. AB and DC are parallel at the same time they are equal in length. So that is a rectangle. So as you can see, this one is what we call rectangle A, B, C, D. So each angle has 90 degrees. And if we're going to add all the interior angles of this rectangle, then it is equal to 360 degrees. A polygon is a closed plane shape with three or more sides. Polygons may be classified according to the number of their sides. It is easy to name polygons if you know these prefixes. So for this one is 3, okay? This one is 3. So 3, tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca, 11 undeca, and a polygon with 20 sides is called icosagon. So this one, 3 sides triangle, 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 is hepta, 8 octa, octagon, 9 nonagon, 10 decagon, 11 undecagon or hendecagon, and 12 is dodecagon. So we have also an irregular polygon. It is a polygon does not have all sides congruent and all angles congruent. It means that it has different sides and different measurement of angle, while a regular polygon is a polygon that has all sides and angles congruent. So these are the examples. As you can see in this one, all the sides are different in length and all the angles are different in measurement. That's why we call this as irregular polygon. But since it has 1, 2, 3, 4, 5 sides, it is pentagon. Next is this one, hexagon, irregular again, because all the sides, okay, are different in length as well as the angle. But since it has 6 sides, this one is a hexagon. Next is heptagon. So as you can see, different in sides, length of sides, and of course, also the angle. But since it has 7 sides, this one is what we call heptagon. So next is regular polygon. So when you say regular polygon, all the sides and angles are congruent. So this too is an example of regular polygon because all the sides, okay, are the same in length as well as the angles. So this one is an example of regular polygon as well as this octagon because the sides is 1.5 and it's all the interior angle is 135 degrees. That's why these two are example of regular polygon. So I will repeat for you to determine that a polygon is regular. Each interior angle must be equal and each side must be equal as well. Next is let's proceed to two polygons are similar if they have the same shape but not necessarily the same in shape, the same in size. So this one is a good example of similar. So this one is a good example of similar polygons because as you can see, they have the same shape, okay? But they have different sizes. So this one is example of similar polygon. Next is two polygons are congruent if they have exactly the same shape, the same size and shape. So just like this one and this one. So this is hexagon, okay, because they have 6 sides. And as you can see, okay, if you will compare the length of this side to length of this side equal, length of this side to length of this side equal, length of this side to length of this side equal, length of this side to length of this side 2.83 equal, length of this side to length of this side equal, last one is 2.24, 2.24, 126.87, 126.87, then 90 degrees, 116, 116, 135, 135, 135, 135, 116, 116. That's why we consider these two polygons as congruent because they have exactly the same in size and shape. Another example is this one, triangle ABC. and triangle DEF. So in this side 3.61, 3.61, 3, 3, 2, 2. The same with this octagon. The measure of its side is 1. The same with this octagon. So these are examples of congruent polygons. For your activity, answer check your understanding A and B on page 270 to 271. Take a photo of your answer and send it via private message. Deadline January 15.